Let's welcome our next speaker is Sean Sublette. So Sean is a multimedia meteorologist and owner of Sublette Weather and Consulting. He lives in Richmond, Virginia. He has a bachelor's and master's degree from Penn State and holds an American Meteorological Society certified digital meteorologist designation. He spent 19 years as a broadcast meteorologist, and he's also worked at Climate Central and the Richmond Times-Dispatch. And he has extensive experience in weather communication and climate science education. And, Sean is somebody that I don't think I've ever met you in person, but I feel like we're friends because I see you on social media all the time. I did a podcast with you. So you feel like a friend, even though we've never met. So I really want to welcome you and thank you for taking the time. And let me turn it over to you.
Thank you, Andy. I appreciate that so much. And for those coming in just now, Andy Dessler there with Zeke Housefather have an amazing Substack called The Climate Brink. If you don't subscribe, the first thing you should do after I'm done is go subscribe to their Substack because it's wonderful. And Andy, I want to thank you personally. And of course, Zeke for doing that as well. You talked about how important weather data is, but even the best forecasts, if they don't land the right way with an audience, don't have the value, right? So one of the things that I've been working on in my career is figuring out better ways to communicate what we understand as meteorologists, climate scientists, and really earth scientists in general to the general public so they can take the actions that they need to take. So I call this weathering the 21st century. The photo on the left is from me there in South Richmond in February 1979, back when we got big snows, as they like to say, and a more recent photo when we had a lighter snow here in Richmond in January 2022. Just to recap how I got here, after my time in high school in Richmond, Virginia, I went up to Penn State to get the foundational science. I very briefly worked for a government contractor on the site of NASA Goddard Space Flight Center. I wrote a lot of code, and I realized I didn't like writing a lot of code, that I really enjoyed talking about the weather. So for the next 19 years, I did work as a broadcast meteorologist in the Roanoke-Lynchburg area of Virginia. And I did that till about 2015. And then, as Andy mentioned, I worked at Climate Central. Met some brilliant people there, including Bernadette Woods-Plackey and the staff there, learning about climate science, several climate scientists, and also really started to take on some knowledge of the social sciences, understanding how people react to information. So I took that and then came back home to Richmond, worked for Lee Enterprises, which is the parent company of the Richmond Times-Dispatch, where I did multimedia weather and climate communications. As Andy mentioned, we ran a podcast for a while. I wrote articles, I did videos, the whole bit. So weather communications continues to evolve for those who have been around for a while and remember the 1970s, the little map with the little stickers. It has changed a lot. But the demand for relevant weather information remains high, whether it's on a traditional newscast, via social media, or during online video. And that's why weather apps have gotten so popular, right? And often, I know, Andy, you're probably asked this as well, what's the best one? Well, it depends on what you're actually aiming for. And the role of a lot of the meteorologists today is to be that second source, as people still want human confirmation. As AI continues to ramp up, we want somebody to kind of walk us through, hey, is this right? Hey, this doesn't make sense. What does this actually mean? And the other thing I want to remind people is different apps use different data. There is no big one data set that everybody is using to decide weather apps. So there's no real consistency across weather apps. Some organizations use better data sets than others, but there's no one massive data set for everybody. I want to credit Tim Heller down in Houston about this slide, reminding you that the apps aren't going to tell you everything. What is the key weather message on any particular given day? Is it weather severe? Is it disruptive? Is it a little inconvenient? Is it optimal? Or is it just unusual? So what's the key weather message? Whether it's rapidly changing weather, like when does the bad thing stop? Decision support, well, what should I do next? Or just curiosity, when you see something that's unusual outside. So let's go back to the classic example here of the severe thunderstorm watch, which most of us have had to deal with at least once in our lives, even on the West Coast where we don't typically have severe weather. We'll have some thunderstorms later here in Virginia, we expect. So we'll use this as a rapidly changing weather situation. Phone goes off, you've got a severe thunderstorm watch. What does that really mean? I mean, we've been doing this as professionally since the 1980s, and we still need to remind people the difference between a watch and a warning. Because if it's not part of your everyday experience, you're not going to remember. So it's incumbent upon us to remind people, what does this really mean? Well, it means in the next few hours, the conditions in the atmosphere are becoming very favorable to produce thunderstorms that are going to do wind damage or hail, and sometimes even tornadoes. So, what should I do? Probably nothing immediately, but raise awareness. Hey, there's some bad storms that might come down in the next few hours. Have a plan to be inside if you need that, which leads us to decision support. What are the risks if I'm doing an outdoor event? Let's say I'm having a birthday party for my 6-year-old in the backyard. This thing hits my phone. What should I do? Well, as a meteorologist, one of the things we could do is help. When does the threat end? You get a severe thunderstorm watch for a large area. If you know where you are in that area and you can help the folks, for example, in Richmond, this severe thunderstorm watch goes for 6 or 7 hours oftentimes. But we could say something like, you know what? It looks like the worst window for this is going to be, let's say, between 6, 7, and 8 p.m. So that gives additional information that is absent from the watch through no fault of the Storm Prediction Center, because they do absolutely amazing work there in Norman, Oklahoma. The other thing we need to do better, and we're starting to get better at this as weather communicators and climate communicators, is to relay uncertainties. We all know that we don't know everything, but there are certain things that we can narrow down, like the specific time frame that we think storms are most likely. And we can tell you when that threat is cleared. Maybe the severe thunderstorm watch goes till 10 o'clock, but we know once this particular line of storms moves through, maybe by 8:30, it's all clear after that. And then we go back to unusual weather, improving the messages. And this is where we do a lot of unwinding of terms that have become very popular in the media landscape, like the polar vortex. And I encourage people, don't overthink big terms like this. This is an unusual weather phenomenon to the average person. So be rather with a basic answer. I mean, it's a regular circulation of very cold air around the North Pole, South Pole too. But most of us here are living in the Northern Hemisphere, and it travels in waves. Sometimes one of these waves moves a little farther south, unloads some Arctic air, and it comes down for a little while. Don't overthink it. I mean, we go on and on about the tropospheric and the stratospheric polar vortex and all that stuff. But at the basics, a lot of the public's not going to remember that. But if you draw them a quickie picture, give a brief explanation, that normally works. And now in this social media age with so many photos running around, these are things that have always been out there, but people see them more often now, like a hole punch or fall streak. You've just got these very, very cold clouds high up in the atmosphere, cirrus and cirrocumulus clouds, and they're kind of in this equilibrium. And if something flies through there, it disturbs the equilibrium, and you have these super cooled water droplets and ice crystals that begin to congeal. They weigh down and they fall in that kind of circular pattern. And you see that kind of feathered nature to that. Those are the falling ice crystals, which then tend to evaporate entirely on the way down. But it leaves this kind of unusual pattern in the sky that frankly freaks some people out. Speaking of that, I don't know a meteorologist that hasn't dealt with this. The condensation trails, jet exhaust simply contains water vapor. And jets 30 to 40,000 feet up in the sky are flying through some very cold air. Now, if that ambient air is close to saturation, the vapor that comes out of the back of that jet is going to condense and form a cloud. But this doesn't always happen. I mean, if the air is still cold, but very dry, the exhaust just remains invisible water vapor, and we end up not seeing any actual condensation trail. But it's amazing to me that we still have to somehow explain this every week, something that I've known basically since I was a child in the 1970s. So going back to misinformation and understanding how to improve messages, we can fold this up into climate science. And it's important to know that communicating climate change, as I'm sure Andy will tell you, is a challenge because it seems to a lot of the general public as something that's psychologically distant in both time and space. But of course, the impacts are already here in hotter days, heavier precipitation, and sea level rise. So, to borrow, if not steal, from Catherine Hayhoe, who I just adore, it's important to meet people where they are about this particular topic, which means we have to come to terms with public perspectives. This is from Ed Maybach and Tony Lizerwitz. They do fantastic work there, understanding how people perceive climate change and global warming. And most people are at least alarmed or cautious or concerned about this. A much, much smaller minority of folks are disengaged, doubtful, and dismissive. But you also have to think about who are you talking to? Where do you want to reach them where they are with common values and come to some kind of conclusion together? And for this, I love to use analogies. This is one that Jim Gandy from South Carolina, I think, taught me first. I was in Philly for a while, so the Rocky analogy plays here. Weather throws the punches, but climate trains the boxer. I'm a Penn Stater, as you could probably see back there. Weather's one football play, but climate's the whole season. I mean, this time of year, we can flip it and say, weather's one inning in a baseball game, but climate's the whole season. And there's a lot of gaming going around nowadays, so I like to think of it as loading the dice. Weather is one roll of the dice, but climate loads the dice. So think about it this way. If you've got a pair of regular six-sided dice, and you take one of them, change one of the faces from a 1 to a 7, and then just roll it over and over and over again, you're going to get different results than you got in the past. On occasion, you're going to roll a 13, and you never roll snake eyes again. And that way, you've loaded the dice toward warmer weather or higher rolls in this case. So this is how we are loading the climate dice toward warmer weather than we have just a generation ago. And these are the kinds of things that I like to pass along to people who have questions about climate change. And where you can show connections to things that are intuitive to people, does it seem like it's hotter? Well, you're right, because we're having way more hot records than we used to. And get in front of some of the myths. Yes, we have an urban heat island, but that makes the warming climate even worse. By the way, the Arctic is warming 3 times, perhaps 4 times faster, depending on who you're talking to at NASA. And there's not a lot of big cities in the Arctic, so that's not all that's going on. And the polar bear thing is still out there, but the key here is that our current global society, increasingly global society, energy, business, agriculture, health, trade. These are all based on the climate from the late 19th and most of the 20th century. So we as humans are going to have to adapt to what we have been dealing with, and what are going to have to deal with in the coming decades to century plus. So it's us and our livelihoods and our lifestyles, not just polar bears. And also give actionable information at the end. I mean, you don't want to just leave people with this information. So 3 little things: you can reduce food waste, which is going to any number of levels. But you hear about the carbon footprint, right? Getting food to market, but eat what you take what you eat, right? My mama taught me that back in the 70s. Rotting food produces methane, which is another greenhouse gas. Carbon dioxide is obviously the bigger one. Eat less meat. This gets a lot of noise. I would never tell anybody to stop eating their hamburgers, but I think we all know that too much red meat isn't good for your system either. I mean, my doctors told me that. But they also take the most energy and resources to raise. I'm not going to tell everybody they got to go vegan, but that's just the mathematics of it. And change the light bulbs if you can. The LED, light emitting diodes, much better than the CFLs and the old-fashioned incandescent light bulbs, and it tends to be cheaper, right? So we also are trying to remind people that they should not despair. We have made progress. There is a long, long way to go, right? But about 20 years ago, there was much more grave concern when coal was still being burned just in a maddeningly way. There's grave concern about a worst case scenario, global increase of 9 or 10 degrees Fahrenheit by 2100. Coal is on the decline, mostly because natural gas is cheaper, to be honest. But that scenario, and Andy, throw back at me if you think I'm wrong, but it's almost been eliminated Battery technology continues to evolve, which helps store things that we get from wind turbines and solar panels. We're already seeing a whole wind farm being developed, should be operational in 2026 offshore from Virginia Beach here in the Commonwealth. That's a photo I took of a solar farm just outside of my hometown here in Richmond, Virginia. So leave people with actionable information, but be realistic. We're all here over these 100 hours to be realistic. What are some of the real world implications for the NOAA cuts? That's a classic WSR 88D Doppler radar, and there's more than 100 of these all across the United States watching the weather for us 24 hours a day, 7 days a week. So what kind of things could happen? This is just one idea. The staffing is down. Meteorologists and technicians have either been fired or taken early retirement. So that means there are going to be fewer around during severe and or damaging weather. Maybe somebody has to be called in. They're tired. Maybe they have trouble with some of the algorithms reading the radars, and you have trouble getting the warnings out. This also means there could be less reliable data collection and distribution, information technology. There's fewer staff to ensure data is being received from our multiple satellites, radars, thousands of ground sensors across the country, getting all this data into one place so the meteorologists can actually produce products that help and save lives. And hardware breaks. These radars started going online when I was an undergraduate in the early 1990s. So it's getting old and it needs maintenance. If a radar goes down, it might take longer to get serviced. If you don't have a technician on site and a radar goes down, maybe it's down 2 hours in the old days, but maybe you've got to call somebody in, they got to order the part, and a radar is down for a couple of weeks rather than a couple of hours or a couple of days. And when that happens, if you've got storms running through, especially this time of the year, severe weather season, there's a real risk of missing dangerous storms. I like to tell people we're not going to miss hurricanes. They're big, right? But a lot of damaging storms like tornadoes, severe thunderstorms are very small with respect to the size of the entire atmosphere. So they have very definable radar signatures, and they can be missed if the critical hardware is down or some people are more tired than maybe they ought to be. And maybe a warning doesn't go out, a tornado is missed, and there is damage or something worse. So there's a lot of things with the NOAA National Weather Service cuts that concern me as a person, as a meteorologist. This is just one of them. So we're all here to raise awareness about this, that these cuts to weather, climate, NOAA, National Science Foundation do have repercussions down the line. They may not seem obvious right away, but another analogy I'll use is this as we wrap up. Let's say it's a nice October afternoon, it's 68 degrees outside, and your power goes out. And maybe you're fine for a few hours, a few days, but by the time winter comes around and you don't have any heat, you're going to wonder what happened. If you don't service your car, you don't notice it for a day or two. You don't service your car for 4 or 5 months, you're going to notice problems. So these are things I try to remind people that what's going on now may not be obvious, but it will have repercussions later on. With that, as they say, Andy, I will yield my time and happy to take any kind of questions now.
Thanks, Sean. That was really interesting. I've got a bunch of questions. Let me just see. See if we have any. Someone, Astra H wants to know where the crab cakes watch versus warnings meme is. That is really a good. That is a good one. Google it. Google it if you haven't seen it, especially if you live in the Maryland area.
I've seen the cupcake version of that too. I've seen the taco version of that too. Yeah, but we've just got to remind people of that all the time.
That's right. Andrew Williams says we've hit 1,000 viewers. So let me just say thank you so much for everybody who 100 to the 1.5. I guess is that 1,000? I presume it is. So I have a couple questions for you. First of all, or this is more of a comment. You're talking about contrails, and most people don't know that a lot of the stratospheric research started in World War II because they wanted to figure out how to not leave a contrail. I mean, if you have a bomber flying to bomb Germany and there's a contrail, it's like a big arrow for the anti-aircraft to see, and they say we don't want to leave contrails, and they did a lot of research in the stratosphere on that. And so this really goes back a long way, but I still have people contact me about, these are, they're spraying aluminum and it's very similar to the people who contact you about, like, we control hurricanes. We're trying to punish people who didn't vote for Biden. I mean, how do you respond to people that, that reach out to you with this crazy conspiracy stuff like this?
I've been inoculated from a lot of that since I've left the general media space, and now I'm working more as a private consultant. But I still see it, and I try to ask people to bring their evidence, and that normally they start going down a rabbit hole, and I'm like, I've been doing this for a long time. I think I'd know. And this goes back to the beginning of the presentation. There is a real problem with the information infrastructure in the country overall, or else we wouldn't have these problems. There's a betrayal of trust, and we could go down a rabbit hole about why that is. But if believe you me, if there was something going on up there, I'd let you know. But all you can do is, hey, can you give me some evidence? Can you give me some evidence? Where did you hear that? Where did you see that? You don't have to go in and just tell somebody you're loopy, you're crazy, because that's antagonistic. But go, now where did you see that? Now why would you believe?
So I've gotten emails, and I'll actually do that. I'll say, why do you think that? And then they have pages and pages of evidence. And they sent me a satellite loop that showed the sky was clear, and all of a sudden these clouds showed up. And they said, what's going on? It's like, I wrote back and said, what's going on is you're lifting air near the surface. There's a lot of water vapor into the upper atmosphere, and it forms clouds. Yeah. And it's like, oh no, that can't be it. It's these HARP radars.
The HARP thing, yeah.
The HARP thing. I mean, it's just I guess I've learned just not to engage.
A lot of times I just kind of back off, and sometimes people just want to fight, and I'm not going to go through that trouble. And it's kind of sad, but you have to manage it the best that you can.
So another question I had for you was about the term polar vortex, because in the stratosphere we talk about polar vortices, for a very long time, because it's a structure in the stratosphere. The ozone hole forms within the polar vortex in the southern hemisphere, and then it's made its way to sort of popular lingo. I mean, what's your thought about that?
Working in the media for as long as I did, it's a good, catchy term. Vortex is a scary word. Polar is a scary word. You put them together, it gets eyeballs, it gets clicks. And it's funny because, we've known about the polar vortex since we were undergrads, right? To us, it's just another word. And it's like, oh, I hadn't thought about kind of framing it that way as big, scary thing, because it just is what it is. So I try, and again, stratospheric, tropospheric, there's different fundamentals going on here. But if I'm trying to leave something in somebody's head that they can go tell their friends, that's pretty darn close. Because look, we don't want to go do a dissertation on the polar vortex for the general public. They're going to get lost. But if we can leave them with the essence of what this thing is, all right, and how it actually works, that they can share, I think we've done something. And this is the challenge of all science communications. How much of a shortcut do you take to give some actionable, good information to the public so they don't go running off thinking something that is more horrible than it is?
So there's one last question from the chat from G. Willikers. Question: I work outdoors in rural Tornado Alley. These warnings are life or death. Now with our tornado range shifting and enlarging, how can we get more safety lessons out to these new areas?
Well, the thing about tornadoes, and my mind has shifted on this a lot since I was an undergrad. Most tornadoes are not F5s and F4s. Most, right? We know this. So most tornadoes, if you were simply inside, away from windows and the lowest floor, you're okay most of the time, right? I think cell coverage is good in most locations to get warnings to your phone, but it's not everything. As I will echo what my colleagues say, have two ways to get a warning. There's still weather radio out there. I've got a weather radio right over here, in addition to my phone. So these two things in concert will normally protect you. The phone, a weather radio. I'm not a big fan of sirens at all. I think a lot of people they're unreliable. I understand that they're used in large rural locations for good reason, but I'm also concerned that they are not utilized correctly. They're not tested sufficiently. And sometimes people hear sirens and they just don't. Well, what does that mean there's a tornado? You and I have a certain age, Andy. Are missiles, are we being attacked? Is it time to, that kind of stuff. So that would be how I approach that.
Okay, Sean. Well, thank you so much. Let's give Sean a round of virtual
Thank you,
applause.
Eddie. And thanks to everybody.